We begin with the search for an alternative explanation by reconsidering the experimentally determined correlation function. Alice and Bob have each chosen an angle, and thus their measuring axis, using their respective polarization rotators. Consider an individual measurement of Alice and Bob. How photons really look is not known by either Alice or Bob, or by anyone else. What we, or our technical aids, perceive is only indirect messages of the photons, which are transmitted to us by various messengers. The senders remain hidden and invisible. As a messenger from the quantum dimension, we imagine Quentin, the Bantam of Solace. Any other messenger would have just as much or as little to do with the sender as Quentin. A postman also only brings the mail to where it is supposed to be left, is, however, not responsible for the content of the mail. Next, Alice carries out her measurement. She can only access a single angle pouch, alpha, of Quentin. When digging into the pouch, Quentin immediately disappears. Only a black or a white card remains in Alice's hand, as a symbol of transmission or reflection. After the measurement, it is impossible to retrace which measurement result would have been realized had Alice chosen a different angle pouch. Quentin, the postman, cannot draw any conclusions about it, because he irrevocably disappeared with the measurement. Next, Bob carries out his measurement. Also, he can only access a single angle pouch, beta, of Quentin. The quantum once again disappears once the measurement is taken. Only a black or a white card remains in Bob's hand. Alice and Bob next conduct a lot of measurements. In this example, they always select angle pouches that are at an angle of 90 degrees to one another. Alice and Bob can only compare their measurement results with one another in order to determine the correlation function C if they exchange the information on their measurement results. The two patterns are anti-correlated at this angle.